Question number 10, it's optimization. They are relatively easy questions because they tell you what to do. Let's look at 10.1. You are asked to find or to determine the initial height of the stone above the ground. So if a stone is thrown upward and its height is given by h of t, which is minus t squared plus 6t plus 16. So the initial height, 10.1, is when t equal to 0, before the recording starts. So we are saying h of 0 will be equal to negative 0 squared plus 6 by 0 plus 16, which will simply give us 16. And for this one, you can easily read the answer from h of t, because when t is 0, this will be 0, that will be 0, you remain with 16. So it's easy, you may not even show these workings and write the answer. So we are simply saying here, initial height is equal to 16 meters. In other words, we are saying by the time you start counting, the stone has already been thrown and is 16 meters above the ground. 10.2, determine the time taken to reach the maximum height. Now, we are looking at our h of t. It is a quadratic. And if we check, if we are to draw the graph of this, it will have this shape. It's concave down. So that's why the question is talking about the maximum height. So it's a question of how do you find the coordinates of the turning point. And here they are saying determine the time taken. So we don't need actually the height, but we want the time taken. So we know that for the turning point we go for the first derivative. So we need the first derivative of h of t, which is negative 2t plus 6. And we equate this to 0 because we are saying the gradient at the turning point is equal to 0. So therefore, minus 2t plus 6 is equal to 0. And transposing positive 6 minus 2t is equal to negative 6. Therefore, t is equal to 3. So we are saying it will reach the maximum after 3 seconds. So the stone will reach maximum after 3 seconds. Then 10.3, determine the acceleration of the stone. Acceleration is simply the change of the speed or the velocity. So we are going to go for the second derivative of our speed function. So we need the second derivative of h of t, which will be equal to negative 2. So basically we are saying acceleration is equal to negative 2 meters per second squared. And then 10.4, how fast was the stone traveling when it hits the ground? So how fast, that is the velocity, by the time the stone will hit the ground. So remember, h of t is the height of the stone above the ground. So when it hits the ground, it means its distance from the ground is 0. So we are saying h of t will be 0 when the stone hits the ground, which implies to say negative t squared minus plus 16 plus 16 will be equal to 0. So this is a quadratic equation which we should be able to solve, and also solve it using factorization. Of course, the first thing is to multiply throughout by -1. That will be t squared minus 16. Minus 16 is equal to 0. And factorizing this, we'll have t minus 8 into t plus 2 is equal to 0. So our t will be equal to 8, or t will be equal to -2. So just looking at the answers, remember our time starts at 0. So t equal to -2 is not applicable in this situation. So basically we are saying the stone will hit the ground when t is equal to 8. So when t is equal to 8, what is the speed? How fast was the stone going? So we have now to substitute t in our velocity function. So we are saying, therefore, the velocity when t is 8 will be equal to -2 by 8 plus 6. That is minus 16 plus 6, which will give us -10. So -10 meters per second. So that is the velocity of the stone. Just showing that it's coming down, it's not going up. So this is basically how you are supposed to answer question number 10.